Example 3. Electrical devices should operate effectively within a specified temperature range. Outside the operating temperature range, the device may fail. So think for a minute of your cell phone, which they have a picture of over here. Has anyone ever left their cell phone sitting out on a hot summer day on the cement and your cell phone just shuts itself off? I know my cell phone has done that because it gets too hot. Letter A. Write and solve a compound inequality that represents the possible operating temperatures in degrees Fahrenheit of the smartphone. Now, let's take a look at the smartphone over here. It says that the operating temperatures have to be between 0 degrees Celsius to 35 degrees Celsius. Now, your phone has to be within that range from 0 to 35, which means it has to be above 0 and below 35. Think about that. If we are on a number line, here's 0 degrees Celsius, here's 35 degrees Celsius, and your cell phone has to be above 0, but below 35. Is this going to be an AND statement or an OR statement? This is an AND statement because it has to be both. It can't be below 0, it can't be above 35, otherwise the cell phone's going to shut off. So I'm going to start and I'm going to say, first of all, we're dealing with degrees Celsius, and my temperature has to be between 0 and 35. So Celsius degrees has to be less than 35 or more than 0. Can it be equal to? Well, it says that the operating temperature is anything from 0 to 35. So yes, if it's at 0, it's still going to operate. If it goes below that, then we have a problem. If it's at 35, it's still going to operate. If it goes above that, then we have a problem. So this is a good compound inequality, but it said that it has to be in degrees Fahrenheit. That's a problem. So now we have to go back through our notes. I forget which section it's in, but we have to find the formula that converts degrees Celsius into degrees Fahrenheit. And if we forgot, we know that Celsius equals 5/9 times degrees Fahrenheit minus 32. That's our conversion. So I'm going to use our substitution property, and I'm going to take this, and I'm going to substitute it into my inequality over here so that I'm working with degrees Fahrenheit. And I'm just going to come down here and write it, so just ignore letter B for a minute. So 0 is less than or equal to, and then I'm going to substitute in my Fahrenheit, 5/9 Fahrenheit minus 32, and then less than or equal to 35. Now, that is the inequality that we had to write, but now we have to solve it to figure out, okay, well, how many degrees is that actually? Because this is an intersection, we have to solve two separate inequalities. So we're first going to consider the left-hand side, 0 less than or equal to 5/9 F minus 32, and the other side, 5/9 F minus 32 less than or equal to 35. Okay, I'm going to start on the left over here with this green one. So we have this fraction 5/9. Easiest way to get rid of a fraction is to multiply by the reciprocal. So the reciprocal of 5/9 means flip it upside down, and we're going to multiply by 9/5. Same thing over here, big parentheses, we're going to multiply by 9/5. Over on the left, what's 0 times anything? And the answer to that is 0. So 0 is less than or equal. Now over here, the 5 in the numerator will cancel the 5 in the denominator. the 9 in the denominator will cancel the 9 in the numerator, and then we're just going to be left with this f minus 32. At this point, we can add 32. So 32 less than or equal to f, which is telling me if I read this the other way, my degrees Fahrenheit has to be more or equal to 32 degrees in Fahrenheit. So it was more than 0 degrees in Celsius, but if we're looking at Fahrenheit, it has to be more than 32 degrees. Otherwise, it's going to be too cold and it's going to shut off. Do we know what 32 degrees is in Fahrenheit? I think it's actually the freezing temperature. Okay, so and. Okay, over here, we're going to start the same way. I want to get rid of 5/9, so I'm going to multiply by 9/5. So the 9 in the numerator will cancel the 9 in the denominator. The 5 in the denominator will cancel the 5 in the numerator. So on my left side here, I'm going to be left with f minus 32 is less than or equal to. For this one, I would probably recommend using our calculator. So I'm going to bring up Desmos. Remember, desmos.com. Under Math Tools, we want to use our scientific calculator. And then we're taking 35 times 9 divided by 5. Hit enter, and that's going to give me 63. Back to our lesson, 63. After we do that, we can add 32. So f is less than or equal to 95 degrees. That's pretty warm. Now, I would totally take this as your answer if we want to practice writing those compound inequalities, because this is an and. We can put our f in the middle, degrees Fahrenheit. We know that it's between 32 and 95, so f is between 32 and 95, less than or equal, less than or equal. So if we read it from this direction, f is less than or equal to 95 degrees, or f is greater than or equal to 32 degrees, which means your phone is only going to function above freezing and then, below 95 or at 95, which is a pretty hot day. Okay, now we have to scroll back up and complete letter B. Letter B, describe one situation in which the surrounding temperature could be below the operating range and one in which it could be above. So think about a situation where the surrounding temperature, meaning the temperature in the air or wherever you're at, is below 32 degrees Fahrenheit. So the example that I'm thinking of would probably be winter in Alaska. And I'm going to put a B for below. So if you're in winter in Alaska, you're probably below 32 degrees Fahrenheit, which is freezing, and it's going to be really cold, and you're going to have to keep your cell phone somewhere safe so that it doesn't shut off. As for one where it could be above 95 degrees, well, then I'm going to put an A for above. I'm probably thinking daytime in the desert. So there's the Mojave Desert, there's other deserts, probably in the middle of summer, daytime in the desert, it's definitely going to be higher than 95 degrees. There's even days here in Utah where it's 100 degrees, 103 degrees. Don't leave your cell phone out sitting on your porch on the cement, or it's probably going to shut off.